Hello. Last week or 2 weeks ago, I did this sort of like hard edge blend fade into a curvature continuous surface in SolidWorks. And since I also use Rhino, I figured I built the same geometry in Rhino and kind of go through the steps and just kind of see the difference. Um, I've already set this up with some basic curves and some reference surfaces. I'm assuming that if you're watching this, you kind of know how to set that up. So basically, it's the same steps as what I did in SolidWorks. Rather than trying to build this surface and follow the edge, I'm going to overbuild it and trim it back. Because if you follow this, because it's three edges, you end up with a singularity in here, and which is a bad thing. I can actually demonstrate that pretty well. So if you use edge curves, you start off with that guy, this guy, and that guy. So now Rhino does create a surface, but if I turn on the control points, you'll see that a lot of stuff here collapses to a point, and that's very undesirable. What happens there if you offset, because it's collapsed to one point, the offset can oftentimes fail downstream, and that's here that's probably not a problem, but if you have a model that's really complex, you really don't want that. And so we're going to try to avoid that. And the way we do that is by overbuilding and trimming back. So if I set this current, so now I'm going to start off with a sweep one, where this is my rail, and that's my cross section, and that gives me this surface. Now, if I run the watt command on this, you'll see that this is a degree 3 4 control point surface in both the U and the V direction. That's basically the lightest surface that you can get. If we turn on the curvature graph, you can see that it's very nicely behaved, really good curvature, and it's a single span surface. It's if you have one more control point than the degree, it's considered single span, and that basically cannot go have an inflection on itself. So a degree 3 with 4 control points cannot have an inflection, and nor can a degree 5 with 6 control points. So you get this really smooth geometry. And then we get, for the side surface, I'm going to use that edge surf command with 3 curves, this guy. And then if I run the watt command on that, you'll see that I get a single span surface there as well. So I get 2 super clean surfaces to start with that I can trim back and then build my blend surface in between. So I'm going to hide these guys for now so that I have a little more access, and then change that. And so now I'm going to build a pipe. The pipe command allows me to build that circular trim surface that I want. And so I selected that blend curve, and then I'm going to start off with a radius of 6, and I'm going to end with a radius of 12. Accept that result, and so here I have my my trim surface. And the one thing you got to be careful with, this edge, you want to make sure that that's out of the way of the surfaces that you're trying to trim or to split. If it's intersecting that, you will get a split edge in one of those surfaces, which makes it more difficult to build your blend surfaces. And the surf seam command, actually don't know what the official name for that is, allows you to move this. So if I wanted this to be at the top, it's at the top. You just got to make sure that that edge doesn't cross through any of the surfaces that you're trying to trim. And for trimming this back, I like to use split. This is a really simple model, but if you have a more complex model with a lot of surfaces, it can be very difficult to get inside here and trim out the stuff that you want. Whereas if you use split, I want to split that top surface, yes, and I want to use, this is my cutting surface, yes. So now if I hide this guy, I can just simply delete those guys, bring it back, split, objects to split, enter that, enter, hide that, and get rid of that. So that gets us here. Now I need a profile in between these guys, and we want to be curvature continuous, so I'm going to do a blend curve, and I'm going to use this edge and that edge, and this is a little too sharp for my liking. And if you hold down shift and you select this, not this outside one, but this inside control point, it trims back symmetrically, but it also trims back both points in a certain ratio. I believe that the ratio is like if you move this like 1 unit, this one will move 2 units, so they will stay in the same relation to one another. I'm happy with that result. I actually want that to be on my curves layer. Show that, hide that. So now I have this trimmed surface, I have this profile, and I need a profile here. Well, here, if I bring on these guys and select the starting curve, that was the curve that I started with to build that helper surface, and I have really nice curvature on that curve, and so that surface has the same curvature as that curve. So the edge of this top surface and the edge of this bottom surface both follow this surface here, and that has curvature continuity through it. I could put a blend curve in between here, and that'll probably give me a pretty decent result, but because I know that this surface is perfectly curvature continuous, I'm going to split out this center section and use that as one of my profiles to build my final surface. And we can use the split command again, and I'm going to use an isocurve to split. I'm going to split this guy, and I'm going to split it over there, and then I'm going to repeat that. I'm going to use an isocurve, and I'm going to do it over there. So now I have this surface that I know is curvature continuous on both sides. Top surface, side surface, and that curve. And now I can build a sweep, and that sweep I can set my edge conditions, and so I can use the sweep two rails, there it is. I want to use this rail, that's my profile curve. That's my profile curve, accept that. And so now you can see I have curvature as an option here. I can also set it to tangency, but because we know that this surface is curvature and that edge is curvature, I'm probably going to have a good chance of keeping this curvature the whole way around. Change that to my surfaces layer. And so now I can join these guys together, and I get this result. And you can see already that I have a highlight that blends really nicely here, through the edge. You don't see any variation. And then here, because we have basically a 90-degree edge, you can see that that highlight is starting to twist around the corner, which is what we want. And then if we run a zebra map on this, you see that through this area here, if I set them to horizontal, I have this beautiful curvature continuity through this area, and then as we get to the edge here, it changes direction, but we have this nice blend in, in the surface there. So you can set an EMAP on this as well, environment map. Check that. That gives me, I like this one. Fluorescent tube, so that basically shows you what the highlight is doing. You get this one highlight that travels, and here we have it traveling around the bottom, and then it travels through the transition. You can't actually see where the transition is, and then obviously as we get like more of a 90-degree curve, the light bends around, but we have really smooth transitions between that. So this is a result that I'm pretty happy with. We can mirror this over, and if it's not perfectly matched, we can actually trim these back, match them on the other side, and then do the same procedure. But for now, I think this is good enough. Cheers.